Hey there, I'm Nix, and as you can see from the screen, I'm doing things a little different for this video, for reasons. Don't worry, we're still going to solve a problem, and I'm still going to give you the details of the entire process, through the planning of the algorithm, to the coding of it, to the analysis of time and space complexities, as well as looking at the LeetCode rankings. If that sounds interesting to you, and especially if you are someone who is still learning to code, is perhaps new to the LeetCode website, and you're wondering where to start, then especially for you, stay tuned. Welcome back. Now that I've completed making videos for the problems that exist in the array and strings explore card, I wanted to take some time to solve some additional problems on, well, the problem lists before I tackle the next explore card once I figure out which one I'm going to do. So if you have not seen this part of the website before, this is where all of the problems on LeetCode are listed. And as you can see, we have close to 2,000 of them. That's a lot. And on this page, you can search for problems based on a wide variety of characteristics. For example, you can tackle some that are made in pre-created lists, like the top 100 like questions or top interview questions. You could say sort them by which have the easy tags, the medium tags, or the hard tags. You can sort by ones that you've already solved versus ones that you haven't attempted yet. And of course, you can search via specific topics like solving binary tree problems, solving depth first search, solving arrays, solving strings, so on and so forth. And of course, you can search for them as well. But if you're someone who is new to this site, or someone who is still learning to code, with all of these options, where do you start? Well, the way I would approach it is not by using any of these tags. If I want to just start to get my feet wet and solving problems on this website and building up my coding ability, the way I would do it is by sorting this list by acceptance rate. As you can see, it lists the percentage of accepted answers versus all submissions that that particular problem has from all of the users that have submitted something to it. So you could sort this by either having it give you the hardest problems first, or click it again and it will give you the easiest ones. Now, if you don't have a premium subscription, which I do not, some of these problems that you see in the list are going to be locked and you won't be able to access them. If they don't have a lock, then they are fair game. And this is a good way to find problems to build up your skills on. And this is how I'm going to solve a couple of problems as I figure out which Explorer card to do next. So let's tackle the first non-premium problem here, apparently the build array from permutation problem. So let's get into that. Now once the problem loads, you can see it's a bit different to solving problems that exist within Explore cards. A little bit of a different format, but the same thing still applies. You're still giving template code here in an editor, and you're given the problem. We're going to be given examples, we're given constraints, and we're given, say, a follow-up here. For this video, I'm just going to be concerned with giving you a solution for it. So we're not going to be worried about the follow-up just yet. We're given a zero-based permutation, nums, that is zero indexed. And we want to build an array that's called answer that has the same length, where the value in that array at a particular index is equal to nums I. In other words, it looks up what the value is in the nums array at position I, and then uses that as the index to look up what the value is at that particular position in the nums array. We want to do this for each index that nums has, and we want to return it. And then it gives you some additional information of what a zero-based permutation is, and it's just an array of distinct integers. So here we have handy-dandy examples. Our nums array is this, and our output is going to be this array. And the reason for this is that we want to build up our answer array so that it essentially equals this. The first value of the answer array at the 0th index is going to be equal to this, where, again, I is 0. So we plug in num0 and then evaluate what the value is at that particular index, and we do it for every single one. And then that reshuffles the values that we have in here to different places. And then we have a second one showing the same methodology happening again. Down here we see constraints. The nums array can be as small as 1 or as big as 1,000, and our values that it contains can be anywhere from 0 all the way to equaling the length of nums. And of course, because we're dealing with permutations, we have to have distinct values. So how do you solve this? When you're starting out and still learning to code, if you're struggling with a problem, don't immediately try to find, say, the most optimal version of an answer. First, start trying to figure out an answer that will work. If you can figure out one answer and get it submitted, you can also have access to the rankings. You can see others' code that have been submitted. So it's a great way to learn, and you'll see that further on in the video. But for now, what probably pops into your mind is, well, if the follow-up is giving you an extra challenge of just using big O of 1 memory, i.e. you can't use any extra space, well, let's do precisely that. Let's use extra space to solve this problem, i.e. let's make a new vector that will house our answer. With using that extra memory, we can then loop through the array and then set our answer value to essentially this. Once we've looped through the array, we can just return our answer, and that should be all that is necessary to solving this problem. Moving on to the code, let's see what that's going to look like. First up, let's make this new array. Since we're doing it in C++, every time they talk about arrays, what they're really defaulting to in the code is the vector container. So in this case, we make a new vector of integers. I called it permutation array, and I have pre-allocated its size to equal the size of the nums array. Next up is the for loop. This for loop is a typical one. Our initial index is set to 0. Our loop is going to execute as long as that index is less than the size of the nums array, and the index is going to increment with each loop. Within the body of the loop, we're essentially just going to use this information. Our permutation array at our index is supposed to be equal to this. So I just plop that into the code, and at the end of this loop, our permutation array should be filled with the numbers in the order that we want them to be. The last thing to do is, because this expects a vector of integers to be returned, we simply return a permutation array. And with that, let's start running the code to see if we encounter any horrible red text. Okay, accepted here. Our output and our expected are exactly the same. Great. So let's do the full submission and see if we get an acceptance. We did! Excellent! As you can see here before, it doesn't bring up the graphs, but it does tell you ahead of time where you are in the rankings of the runtime and the memory usage. But before we go to that site where it does have the graphs, let's go ahead and analyze the time and space complexity, or the big O of this code. For space complexity, because we're carving out extra space that is variable because we're making a new vector, the size of the space that we carve is going to be equal to the size of the nums array. And the size of the nums array we can call n. So our space complexity will be big O of n, or linear memory consumption. For our time complexity, we have only one for loop here that's doing some constant work. Now, because this loop is going through the nums array, the number of iterations that it's going to go through is going to depend on again, the size of the nums array, or n. So in addition to having a big O of n space complexity, we have a big O of n time complexity as well. Now, to look at the graphs here, you need to click on your accepted status link, and that's going to send you to being able to see the rankings. You see here, we're pretty good on the runtime, which indicates that since this also looks pretty close to a bell curve, this is probably a range of the same kind of solutions. In other words, there's not a big difference in the big O solutions with the test cases that they have and the constraints that this problem has. It's a pretty good ranking here. Let's go down to the memory usage. We see we're pretty much in the middle of the pack here with one kind of distribution here and another kind of distribution here. This range is probably where the big O of n type solutions, the one that you use extra memory, show up, and this range is probably the ones where the in-place solution goes, ones that don't use extra memory. Now, in mentioning using this for a great learning tool, now that you have a submitted answer, you can see that if I hover over these columns, I can click on them, and when you click on them, they bring up additional sample code that would fall within the runtime there. And this is a great way to see various other types of solutions. And as you can see here, I've clicked on one that actually does list a type of in-place solution. So that's handy. I'm going to close that. And you can do this for all of the columns. For example, here, this one also makes a new vector, but this one doesn't pre-allocate the space and instead uses the pushback function. That is nice, but if, say, we go down here and look at some of these columns, you can see this pushback answer is down here. That's because the pushback function has some additional memory usage that's involved, so it's a little bit more greedy than just if you use the alternative of pre-allocating space ahead of time and then directly assigning it via the index. And say if I clicked on here, I probably, we see another vector here, which tends to mean that your answers and the specific ranking that you see here tends to be variable. You could submit the same code at different times and get different rankings. So take your ranking here with a big grain of salt. So that was how to solve the build array from permutation problem on the LeetCode website. If this video was helpful for you, consider subscribing. And as always, I will wish you happy coding and to have a nice day.